Okay, so I'm making a part two of basically my understanding of computers, because of how fascinating I find them. So yeah, I wanted to talk more about the components inside computers. Bear with me, like I'm kind of shaky because I have a physical disability. So um basically I have covered, I think, transistors, capacitors, resistors, diodes. These are all basically components within a computer, so they would be put in part of the on top of the motherboard along with like electronic circuits. Um, so basically, the power resistor dissipates substantial amounts of power and are typically used in power supplies, power conversion circuits, and power amplifiers. Let me just get my coffee. Okay. Good mornings, lots. Yes. Oh. Um. Yeah. So power resistors typically used in power supplies, power conversion circuits, and power amplifiers. This designation is loosely applied to resistors with power ratings of 1 watt or greater. Power resistors are physically larger and may not be used in the preferred color codes and external packages. Um, and there are lots of like different values that can be applied to resistors, according to like accuracy of power. Normally this is like measured in ohms, I believe. A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmission lines, amongst other use. High power resistors that can dissipate many watts of electrical power as heat may be may be used as part of motor controls in power distribution systems or as test loads for generators. Fixed resistors have resistances that only change slightly with temperature, time, or operating voltage. Variable resistors can be used to adjust circuit elements such as volume control or lamp dimmer, or as sensing devices for heat, light, humidity, force, or chemical activity. Now, these things are like extremely complicated, much more than I'm making them sound, so don't just go and get one without like a qualification. Okay, so diodes, various semiconductor diodes. In most diodes, a white or black painted band identifies the cathode in which electrons will flow when the diode is conducting. Electron flow is the reverse of conventional current flow. And then I go on to discuss electrons within that. An inductor, also called a coil, choke, or reactor. This is like all about like magnetism and iron cores. Moving on to something interesting, which is the system on a chip. So system on a chip components are often designed in high-level programming languages such as C++. Sorry, MATLAB or System C, and converted to RTL designs through high-level synthesis (HLS). Tools such as C to HDL. HDL is hardware description language. And so you've got like C++, Ruby, Java, etc. They're all like coding language, and then you have HDL, which is the language for the actual physical hardware. HLS products called algorithmic synthesis allow designers to use C++ to model and synthesize systems, circuits, software, and verification levels, all in one high-level language commonly known to computer engineers in manner independent of timescales, which are typically specified in HDL, hardware description language. Other components can remain software and be compiled and embedded onto soft core processors. In the system on chip and modules in HDL as IP cores. Now, I think this is really interesting. As an artist, I would probably like to be able to design diagrams which like show what hardware language would look like in terms of an image of an actual core that's an IP. However, I don't know if I'll physically be able to do it. So, hardware description language, termed register transfer level, which defines the circuit behavior or synthesized into RTL from high-level language through high-level synthesis. These elements are connected together in hardware description language to create the full SoC, system on chip. The logic specified to connect these components and convert between possibly different interfaces provided by different vendors is called glue logic. I think that's beautiful. Glue logic. So the logic by which things are like synthesized or put together. And yeah, by Ohm's law, power is current squared times resistance, or voltage squared divided by resistance. The system on a chip, SOC, is its nickname. Also written as system on a chip or system on chip, is an integrated circuit, also known as chip, that integrates all or most components of a computer or other electronic systems. These components almost always include a central processing unit, memory interfaces, on-chip input-output devices, input-output interfaces, and secondary storage interfaces, often alongside other components such as radio modems and graphic processing units, those are GPUs, all on a single substrate or microchip. It may contain digital, analog, mixed signal, and often radio frequency signal processing functions, otherwise is considered only an application processor. So, in computer engineering, logic synthesis is a process by which an abstract specification of desired circuit behavior, typically at register transfer level (RTL), is turned into a design implementation in terms of logic gates. Gates, when it comes to computers, is just crazy. Like, there are so many. Typically by a computer program called a synthesis tool. Common examples of this process include synthesis of design specified in hardware description language, including VHDL and Verilog. Some synthesis tools generate bit streams and programmable logic devices such as PALs or FPGAs, while other target the creation of ASICs. Logic synthesis is one aspect of electronic design automation. Very interesting. Moving on to the processor in computing. In computing and computer science, a processor or processing unit is an electronic component or digital circuit that performs operations on an external data source, usually memory or some other data stream. It typically takes the form of microprocessor, which can be implemented on a single metal oxide semiconductor integrated circuit chip. In the past, processors were constructed using multiple individual vacuum tubes, multiple individual transistors, or multiple integrated circuits. Today, processors are built in transistors. So basically, some of the information that I have gone through is not like the technological advancement that is out there now. So CPUs, central processing units, are the primary processors in most computers. They are designed to handle a wide variety of general computing tasks rather than only a few domain-specific tasks. If based on the von Neumann architecture, they contain at least a control unit, a CU, an arithmetic logic unit, ALU, and processor registers. In practice, CPUs in personal computers usually also connect through the motherboard to a main memory bank, hard drive, or other permanent storage, and peripherals such as a keyboard and a mouse. Graphic processing units, GPUs, are present in many computers and designed to efficiently perform computer graphic operations, including linear algebra. They are highly parallel, and CPUs usually perform better on tasks requiring serial processing. Although GPUs were originally intended to use in graphics, over time, their application domains have expanded and they have become an important piece of hardware for machine learning. There are several forms of processors specialized for machine learning. These fall under the category of AI accelerators, also known as neural processor units or NPUs, and include vision processing units (VPUs) and Google's Tenor processing unit (TPU). Sound chips and sound cards are used for generating and processing audio. Digital signal processors (DSPs) are designed for processing digital signals. It's a lot. Image signal processors, physics processing units, film programmable gate arrays. Synergistic processing elements or units. Okay, let's move on to processing design. So, in computer science and instruction set architecture, ISA, also called computer architecture, is an abstract model of a computer. A device that executes instructions described by the ISA, such as a central processing unit, is called an implementation. In general, an ISA defines the supported instructions, data type registers, the hardware supported for the main memory, fundamental features, memory consistency, addressing modes, virtual memory, an input and output model of the family implementations of the ISA. An ISA specifies the behavior of machine code running on implementation that the ISA in a fashion that does not depend on the characteristics of the implementation, providing binary compatibility between implementations. A process register is quickly accessible location available to a computer's processor. Registers usually consist of a small amount of fast storage, although some registers have specified hardware functions and may be read-only or write-only. In computer architecture, registers are typically addressed by mechanisms other than the main memory, but may in some cases be assigned a memory address, e.g. DEC PDP 10 ICT 19000. Almost all computers, whether load, store, architecture or not, load data from a large memory into registers where it is used for arithmetic operations and is manipulated or tested by machine instructions. Manipulated data is often stored back to main memory, either by the same instruction or by a subsequent one. Modern processors use either static or dynamic RAM as main memory, with the latter use usually accessed via one or more cache levels. A coprocessor is a computer processor used to supplement the functions of the primary processor. Operation performed by coprocessor may be floating point arithmetic graphics, signal processes, string processing, cryptography, or I/O interfacing with peripheral devices by offloading process-intensive tasks to the main processor. Coprocessors can accelerate system performance. Coprocessors allow a line of computers to be customized so that the customer who do not need extra performance do not need to pay for it. In mathematics and physics, vector is a term that refers colloquially to some quantities that cannot be expressed by a single number or to vectors are like big in the whole like arithmetic processing thing. That cannot be expressed by a single number or two elements of some vector spaces. Historically, vectors were introduced in geometry and physics, typically in mechanics, for quantities that have both magnitude and direction, such as displacement, forces, and speed. Such as quantities are represented by geometric vectors in the same way as distances, masses, and times are represented by real numbers. The term vector is also used in some contexts for tuples, which are finite sequences of numbers of a fixed length. I'm gonna leave it there because I'm exhausted. My legs won't stop shaking. And I'll see you soon. Bye.